What's up guys, and welcome to this video about increasing the performance of your Jetpack Compose UI. In this video I will show you 5 common mistakes when it comes to building UI in Jetpack Compose and how to avoid them. First of all, we want to start with the unnecessary modifier calculation problem. To actually show you the problem, I've created this little main screen composable, which will be kind of our playground. And in this main screen composable, we will do it the wrong way first to show or to see the performance issues. And after that, we will increase the performance by changing some things. In this main screen composable, we will have a toggle variable, which can be set to true or false. Inside this column, this button just toggles this variable. And if this variable is true, then we will execute this code here. And this here is a side effect, I know, but we won't cover side effects here. For the sake of simplicity, we shouldn't do this here, and it does not affect our results. And here we create a list and a for loop which adds 10,000 names to our list. And after that, we invoke this name list composable here, which is defined down here. This name list composable has a lazy column which shows all the list items. As you can see, this lazy column takes a text composable and we simply pass it to show the current name. And the problem now is here with this modifier. So this modifier has some common stuff like padding, fill max width, clip. And I've also added this onSizeChanged method, which makes no sense, but it will show us that this modifier gets calculated each time a text comes visible to the user. So if the user scrolls down and scrolls down, then another 20 and another 20 text composables get visible to the user. And this modifier is calculated every time. But this modifier also is every time the same. So we don't want to calculate and allocate resources for it each time a new text composable enters the compositioner. So let me quickly show you this. When we launch this now, our UI will be really laggy. And after that, I will show you a way where it works smoothly, even if we have this 1 million nonsense calculations in it. And before we start it, we should maybe add the I in here so that we can differentiate between the names, so the lag will gets more clear. So when I start this and then press on this button up here, then our toggle will switch to true and show our name list. So now I pressed it, and as you have maybe seen, there was a little delay, like 1 or 2 seconds. And now when I scroll down, I don't know if you noticed this, but it's yeah, it's kind of laggy. Maybe we can also increase this to 2 million and launch it again. And then I think it will be even more clear. Yeah, the delay is like 3 seconds now, and now it's heavily laggy. So I can't even scroll now. To fix this problem now, we can just create a modifier variable. So reusable modifier is equal to, and then we will just copy this and paste it up here. And for the modifier, we will say reusable modifier. And now the resources to calculate this modifier are only allocated once. So since this modifier is always the same, it always does the same calculations, we only need to allocate the resources once, because the calculation does not have to be made more than one time. And by using this value here, we can achieve this. We will only calculate this once and then always pass this reusable modifier down here. And now you can see, even with 2 million calculations here, the UI will run smoothly. So when I press on this button, then you can see, yeah, it works fine. So you can see it's scrolling down smoothly, and also we didn't have a delay at the start. Alright, okay, this was tip number 1, the reusable modifier, to avoid unnecessary modifier calculations. In your projects, you will often have some kind of lists where you pass some composables and you will add a modifier to it. And if this modifier is always the same, then you really should avoid always to calculate the same behavior there. Of course, you won't have that heavy calculations we had here with this 2 million for loop. But if you have the possibility to avoid some unnecessary calculations, then why shouldn't take it? Now we will come to tip number 2. use keys in your lazy lists. In this little example, we have a name list with two initial names here, name1 and name2, and then we have a button which adds another name to this list at the index of 0. Then we pass our name list to our name list composable, which is a lazy column, and this lazy column invokes a name composable for each name. And this name composable then has a print statement so that we can see when it's actually composed or when it enters the composition and is in the composition. And we have also a text which is responsible for displaying the names in the UI. If we launch this, then we can see that our name composable enters the composition for name1 and name2. If we now click on the button and add name3 at the index of 0 to our list, then you can see that name3 here enters the composition and name1 and name2 get recomposed, even though they didn't change. So we can avoid this with a simple key parameter inside our lazy column, so that each item has a unique key, and then Compose knows which items are actually changed and which not. Because right now, because of this index change of each name, Compose thinks that each name has removed from the list and draws it again. So we can easily say in our items here for key, we pass a lambda which needs the key, and here we can simply say it because our names are unique right now, so this is fine. In a real project you maybe would use a separate really unique ID for this, but if we launch this now, then you can see the initial composition for name 1 and 2 happens again, of course. And now you can see that only name 3 enters the composition because name 1 and name 2 didn't change. They just changed from the index. And now with this key here inside our lazy columns items, we can then say to Compose, use this key as an indicator for managing your current composables. So they don't need to be removed and added to the list again unnecessarily because they are just switched by index. This can increase the performance of your UI significantly because each of these items can also be some kind of complex composable which has some heavy initial calculation, so you should always avoid unnecessary recompositions here. Or in this case, if you want to be detailed, it's leaving the composition and entering the composition as a new composable and no recomposition here. Alright, this was tip number 2. Now tip number 3 is about updating your UI less times than your state changes. So if you have multiple state changes and you only want to update your UI every 10th time or something like this, then you should use derivedStateOf. Alright, here we have a counter state which is 0 by default, and then we also start a launched effect which increases this counter state from 0 to 10,000 every 5 milliseconds. Then we have a column with fill max size and a center horizontally alignment. And in this column we have this progress composable. This progress composable takes our counter state, and in here it first prints this state and we can see how much compositions actually entering. And then it also has a text composable which shows the current progress in percent. So we divide the progress by 100 and round it to int, so we get the percentage value. And let me quickly show you the problem here. So let's start this. As you can see, the progress is updated right. So the functionality regarding this text here is good, but let's have a look at logcat. As you can see under the hood, there are tons of recompositions. So each time the state changes, the text is also recomposed, even if the round to int value is not updated. So we have a case here that we want to update the UI less times than our state actually changes. And to avoid this tons of recompositions, we can use derivedStateOf. So in our progress composable, we create a val progress in percentage is equal to remember. And in this remember block, we can then make use of derivedStateOf, which is actually also a side effect handler here, because if we are strictly, this is a side effect which I marked here, this calculation. So we can make this calculation inside the derived state block, and then we can say down here progress in percentage. And for the print statement, we will also say progress in percentage. So what does this derived state of actually does? This derived state of effect handler has some kind of cache inside, and this cache always saves the latest calculation result. And if the new calculation result is the same than the old one, then this derived state of just does not emit any value. So this progress in percentage value here does not get updated, because the derived state of just emits its calculation value if it differs from the last one. And the huge benefit now, since this progress in percentage is only updated if the calculation here differs from the last calculation, so from 1 to 2 to 3, 4% and so on, this composable and print line statement down here only gets executed or gets recomposed if this progress in percentage actually gets updated. So this two lines will only get executed 100 times, and before that we had 10,000 recompositions down here. And in a real project you would not only have a text here, you would have more complex composables and deeper composables and all that stuff, and then saving 9,900 recompositions would be a huge improvement of your UI's performance. Let me quickly show you this by running the application. As you can see, I need to say value here. So, okay, again, as you can see, the progress is again updated correctly. And if we have a look at logcat now, then you can see the composition only occurs if the percentage value actually changes. And this could have a huge impact in your real projects. And maybe in a real project you wouldn't pass the state like this inside such a composable. I know that, but I don't have some kind of custom state generator which generates me that state every 5 milliseconds from 0 to 10,000. In a real project you would have some kind of scroll state, for example, which gets generated by this remember lazy list state, and then you want to show the user a button if he actually started scrolling. So scroll state dot first visible item index. If this is greater than 0, then you know that the really first item isn't shown anymore, and that means that the user started to scroll. And then if this is true, then you can observe this, and then you can show a button go up to the top again or something like this. And you don't want to recompose this button every time this equation here triggers, because it's enough to know that he actually started scrolling, and you don't want to update this button, or you don't want to recompose this button every time this is true, because the scroll state emits every frame a value or something like this. Not exactly sure here, but yeah, this would be a real example use case. So also the general rule here applies: if you want to update your UI less frequently than your actual state changes. Alright, that's it for tip number 3. Now we will have a look at tip number 4, which is about backwards writing. What's actually backwards writing? Backwards writing means that we read some kind of state, like we do in this text composable with our counter.value, which we defined as a state val down up here. And after we read it, we modify or we change it. This means backwards writing. After a state is read, it is changed inside a composable, and we should always avoid this. In this example here, it's kind of obvious that we don't avoid backwards writing, but in a real project this can be not that obvious, so always be careful and avoid backwards writing. I will quickly show you what happens when we launch this. So initially everything is okay, because this effect only takes place if the first entering the compositioner happened. And now when we click on the button and increase this counter here, after that the text will recompose because it reads this counter, and after that the counter will get increased again, and then we will be in an endless loop. This text will read the counter again because it got increased. After that it will be increased as again and again, and yeah, have a look at yourself. And maybe in a real project this could not be that obvious like it is in this case. We see that we have a problem here with our value, but sometimes you have some kind of state changes which are maybe affected by backwards writing, which are kind of hidden, which updates a background value, some kind of little padding, so you won't actually notice it. But yeah, you have tons of recompositions here and a real problem if you do backwards writing, so please avoid this. This was it for tip number 4. Now we will come to tip number 5, which is about reading state. We should always wait until we read state as long as possible. If we read state at the wrong place, then we cause tons of unnecessary recompositions. Alright, to show you the problem here, I've created another example which is also not that real-world example, but I think it demonstrates quite well what's the problem here. So we have a counter which is a state value and 0 by default. With this button inside our column we can increase this value, and then we also do a calculation, a current heavy result, and then we invoke our composable 1, which is defined down here, and we read this counter.value inside our column scope here, and then we pass this as a string down to our composable 1. Our composable 2 will then display our current heavy result, and we also have a print line statement which indicates how much a recomposition occurs. So the problem here now is a very common problem which I also faced a lot in my own projects, and I think you have also done this mistake. So the problem here is this read counter value. We read this counter.value, so our state, inside the scope of this column. What Compose does, if we read such a value, it looks for the nearest parent composable, which is this column, and then it recomposes it, because Compose knows I need to recompose it because there was a state change. And if we read this value here, then this column gets recomposed. But we don't really need this counter.value in our column scope, because we just want to display it in our compose 1. So in this here, so in this text composable, we only need our counter.value inside this text composable. So we shouldn't read it here. We shouldn't read our state value here in the composable 1 parameter list. We should somehow read it here, because when I launch this, I will show you what the problem is. So let me launch this and go at logcat. So we see compositioner composable 1, which is this print statement here, and our column compositioner. And when I click on increase now, then you can see we have, of course, the composition of the composable 1, which is okay, but we also have the recomposition of our composable column. So all this code here, all these composables which are in this column are getting recomposed. Of course, this composable won't get recomposed because the current heavy result is the same, but this current heavy result calculation happens again. And when I click on increase multiple times, this current heavy result will always be calculated, because we recompose this column. And that's because we read this value inside the column scope, because the column is the parent composable of our composable 1, and it looks for the parent composable where a state value is read, and then it recomposes this parent composable. But all this other stuff here, this current heavy calculation, and even the check here for this composable 2, if it actually should also recompose, is all unnecessary because this counter value is only needed in our composable one. So this is the problem here, and maybe you think, I don't care about these two other composables to be checked for recomposition, and also this current heavy result calculation is not that heavy that it makes my UI laggy. But think about this comment here. There can be more composables, there can be more calculations, and yeah, you should always read the state only where it's actually needed. How can we fix this now? The answer is with lambda functions. Inside our composable one function, we can define a function as a parameter. So this will take nothing and return a string. And since this returns a string, we can then invoke this function on text inside our text composable, like this. And up here, where we invoke our composable one function, we can then write it like this and define our lambda function. So we will pass our counter.value. This is the definition for the function we pass here. And since we invoke this function inside our composable one definition, this code only gets executed in here, in this composable one scope. And so we moved the scope from the column scope to our composable one scope where it's actually needed. And now we can relaunch this and have a look at the logcat. As you can see, the initial compositions here with composable one and our column always happens because it's the initial composition. But when we increase our counter now, then you can see only our composable one here gets recomposed. So we read the state here in our text composable inside our composable one scope. Alright, this is it for tip number 5. I've also faced a lot of problems regarding this concept, and even now I do this mistake sometimes. So always check your code and ask yourself if I really need to read this state value where it's currently read. So always read the state where it's actually needed and not on a higher composable. Alright, thank you for watching. I hope you enjoyed this video and can build more performant UI now in Jetpack Compose. If you want to learn more about performance, especially regarding the 3 phases in Compose, which can be sometimes skipped if this situation allows it, then leave a comment and maybe I will do a video on it.